Hello, Algebra 2 people. We're going to continue on with exploring other polynomial equations. So if you could turn your packet to page 24 and I'll take you through what we're going to learn today. All right, so number 1 says, now you know that any quadratic equation with real coefficients has at least one complex root. And in fact, we learned that we could have two real roots. We have one root when it just touches the x-axis, that one root counts as a double root. Or if our graph doesn't cross through the x-axis, we have two non-real complex roots. All right, so that's what we learned about in the past couple of days, but now we're talking about cubic. Cubic equations, we know, follow this sort of path. And so we know that since our end behavior has one end moving down and the other end moving up, or vice versa, we know that we have at least one real root. So that means there must be at least one complex root. All right, and we learned about that because complex roots take into effect or complex numbers take into account real numbers as well as imaginary numbers, because complex numbers have the real part and the imaginary part. All right, so we're going to take a look at how we can find some roots of some cubic equations. And the way we're going to do this first one is with division. Okay, so we're going to divide, and we're going to divide this using long division. All right, and it's going to look a little funky, but it's very similar to what you learned about when you learned how to divide numbers back in the day. So I'm going to take x minus 2, and I'm going to divide that into x cubed minus 2x squared plus x minus 2. All right, so I've set this up. All right, and I'm going to start by looking at just the x, so hanging out as my divisor. All right, and I'm going to look at this x cubed. And I'm going to ask myself, x times what gets me x cubed? And I know that x times x squared gets me x cubed. So I'm going to write an x squared up at the top. Notice that I'm kind of lining this up so that my x squareds are hanging out in line with each other vertically. All right, so now what I need to do is I'll do a little side work here. I put x squared up top, and I'm dividing by x minus 2. So if I multiply those, I distribute throughout, I get x cubed minus 2x squared. Okay, so now my job is to subtract these. And I know x cubed minus x cubed is 0. And a negative 2x squared minus a negative 2x squared, that's like plus 2x squared, that gives me 0. Okay, so I got nothing there, so I can bring down my x minus 2. All right, so this one's moving kind of fast, so that's good. So now I'm going to take a look at my x and my x. And I know that x times a positive 1, okay, so I can put a 1 up here, gives me x squared. Sorry, x times 1 gives me x. So a little side work hanging out here, I have 1, and I'm dividing by x minus 2, so if I distribute that throughout, I have an x and a negative 2. I subtract that down, and I have 0. So I know that when I take x cubed minus 2x squared plus x minus 2 and divide by x minus 2, I get x squared plus 1. I could check this out and do that box method stuff and multiply these together, and that's going to get me back to where I started. All right, so this is polynomial long division. All right, so now if I want to find those roots, okay, so I know that my roots, I have an x minus 2 times an x squared plus 1, and I know this equals 0. So if I want to find my roots, I have my two mini algebra problems. I have my x minus 2 equals 0, and I have my x squared plus 1 equals 0, because 0 times anything gives me 0. All right, to solve this one on the left, I'm going to add 2 to both sides, and one of my roots is hanging out at 2. All right, to solve the next one, I'm going to subtract 1 on both sides. So x squared equals a negative 1. To undo squared, I'm going to square root here. Okay. And the square root of -1 is going to give me a plus or minus I. So I have 3 roots hanging out here. I have 2, I have I, and I have a negative I as my 3 roots to this equation. All right, oh, hanging out down here. They want me to write it down here. All right, there we go. All right, so we're going to try this again. Okay, another sample. All right, so we're going to use long division again, and I'm going to take x minus 4, and I'm going to divide that into x cubed minus 2x squared minus 7x minus 4. Okay, if you're picking up on this quickly, I would encourage you to pause the video, try it out, and then we'll compare. All right, so hopefully you had a chance to try it out. All right, so we're taking a look. We want to look at x and x cubed. And we think to ourselves, x times what gives us x cubed? And that's an x squared. Little side work happening over here. X squared times x minus 4. I distribute that through, and I get an x cubed minus a 4x squared. Okay, I'm going to subtract that. I know that x cubed minus x cubed gives me 0. A negative 2x squared minus a negative 4x squared. I know that minus a negative is like plus a positive, so I get a positive 2x squared. And I'll bring down my other terms. Okay, this next time through, I'm taking a look at x and my 2x squared. And I'm thinking to myself, x times what gives me 2x squared? And I know that's a positive 2x, so I'll put that up above. Okay, little side work hanging out over here. Okay, 2x was hanging out up top, and I'm dividing by x minus 4, so I'm going to distribute that throughout. 2x times x gives me 2x squared. 2x times a negative 4 gives me a negative 8x. Okay, I'm going to subtract these. 2x squared minus 2x squared gives me 0. Negative 7x minus a negative 8x minus a negative turns into plus a positive, so I have a positive 1x minus 4. Okay, it's so much fun. I'm going to do it one more time. This time I'm looking at x, and I'm thinking to myself, x times what gives me x? And that's 1. Okay, so 1 times x minus 4 again. Distribute that through, and I have an x minus 4. If I subtract these, x minus x gives me 0. Negative 4 minus a negative 4 gives me 0 as well. All right, and so when I divide these out, I end up with x squared plus 2x plus 1. All right, so I can take this even further because that x squared plus 2x plus 1, that's a trinomial here, and I can try to factor this guy. If I'm trying to factor it, I know that x squared hangs out in the top left corner. I'm looking for 1 in the bottom right corner. Hanging out in front of my x squared, there's a 1, so I'm taking 1 times 1 to give me 1. And I'm looking for factors of 1, things I multiply together to give 1, but add to 2. Okay, and those factors are a 1x and a 1x. So I'm going to put a 1x and a 1x here. All right, if I go through by row, the things in the first row have an x in common. Okay, and the things in the second row have a whole lot of nothing in common, so I can always pull out a 1. Okay, looking at my first column, x squared and 1x have an x in common. And then 1x and 1 have a whole lot of nothing in common, so I can always pull out a 1. All right, so that gives me x plus 1 times x plus 1. Okay, remember at the very beginning, all right, I'm running out of room here, so I'm going to shrink this all down. All right, try that again. At the very beginning, I divided by x minus 4, so I know x minus 4 is a factor. And when I divided, I got x plus 1 times x plus 1 as factors. So now this thing is totally factored. I'm looking for what makes this 0. All right, at this point, I have some mini algebra problems to take a look at. So I have x minus 4 equals 0. I have x plus 1 equals 0. And then the exact same thing again, x plus 1 equals 0. Okay, I'm going to solve each of these things. Okay, add 4 to both sides, I get 4 as one of my roots. Subtract 1 on both sides, I get negative 1. Same equation again, so I'm going to get a negative 1. Notice here, I have negative 1 twice, so this counts as a double root. Okay, so it's just going to touch the x-axis at negative 1 and bounce on back. So my factors are 4 and negative 1. Or sorry, my roots or solutions are 4 and negative 1. All right. Well, long division is all fine and good, but there's a faster way. Okay, there's this other thing called synthetic division. Okay, I prefer synthetic division. All right, and if we're dividing by x minus 4, I'm going to start by solving x minus 4 equals 0. All right, so to do that, I'm going to add 4 on both sides, okay, and x equals 4. Now that I know that, I'm going to set up my synthetic division. All right, so I'm going to put 4 in this little box thing in the upper left-hand corner. And then I'm going to take a look at all my coefficients. All right, I have a 1x cubed, I have a negative 2x squared, I have a negative 7, and I have a negative 4. All right, so I'm going to ignore all the variables, okay? And it looks like I'm not missing anything. It's going x cubed, x squared, x, and then my constant, so I'm not missing anything. So now I'm going to put in my coefficients. I have a positive 1, I have a negative 2, I have a negative 7, and I have a negative 4. All right, so now we're going to use synthetic division. All right, so I'm going to put in this horizontal line here and put another little box hanging out on the very right-hand side of my line. All right, so here's how synthetic division works. We always bring down that first term. Okay, so 1, 1. All right, so then I'm going to take 4 times 1, and 4 times 1 gives me 4. Okay, I'm going to add down in my column. Negative 2 plus 4, that gives me a positive 2. All right, next thing I'm going to do, I look at my 4. I see my 2. I'm going to multiply those together. 4 times 2 gives me 8. Okay, again, I'm going to add down in this column. Negative 7 plus 8 gives me a positive 1. All right, one more time. I'm going to take this 4 times 1. 4 times 1 gives me 4. Okay, I add on down. Negative 4 plus 4 is 0. The thing hanging out in this last box on the right side of this little line, this is my remainder. So I know that x minus 4 divides evenly here. Then I have my plain old constant, so my number. I have my x term, and I have my x squared term. So just like before, same problem, I'm getting a 1x squared plus 2x plus 1 as my answer. And then from here, I could go ahead, just like in that previous problem, and box method it up in order to factor that thing to again find that my factors are 4 and negative 1. All right, cruising on. Okay, we're going to try another one with synthetic division. Okay, so we know in this problem, we're told that x equals 2 is a root of our equation. So in the little box hanging out in the top line, I'm going to put in 2 because that's my answer. All right, so we're going to divide that into, so x minus 2, we're going to divide that into 1x cubed minus 2x squared minus 1x plus 2. So I'm going to write down all my coefficients. I got a 1, a negative 2, a negative 1, and a 2. Okay, get my line cooking underneath, a little box for my remainder hanging out at the bottom right side. All right, so I'm going to follow through here. I start by dropping down the first term, so I'm going to carry down the 1. All right, and then I'm going to take 2 times 1, and I know 2 times 1 is 2. I add down the column, negative 2 plus 2 gives me 0. All right, taking a look at the next piece, I'm going to take my 2 times 0. 2 times 0 is 0. I'm going to add down my column. -1 times 0 is -1. Okay, one more time. I'm going to take 2 times -1. 2 times -1 is -2. Add on down the column, and I get 0. Okay, so I have no remainder, which means that 2 divides evenly. Okay, I have my constant, so my Plato number. I have my x term, and I have my x squared. So when I divide it out, I have x squared, 1x squared, minus 1 equals 0. Okay, so that's what I got here. So at this point, I'm going to try to take a look and try to factor this x squared minus 1 business. Okay, keep in mind you could always use the quadratic formula here if you'd like. Okay, you could also use the box method, but I'm going to take a look at this difference of squares business. Okay, so difference of squares says if I have an a squared minus b squared, I can factor this by taking my 2 base terms, so a and b, and adding them in one set of parentheses and subtracting them in the other. All right, so I'm going to use that to help me out. I know I can square x to get x squared, and I can square 1 to get 1. So my base terms are x and 1. So to factor this thing, I can add those base terms together in one set of parentheses and subtract them in the other. Okay. So if this whole thing has to be equal to 0, I have my 2 mini algebra problems. I have x plus 1 equals 0, and I have x minus 1 equals 0. Okay, so I can subtract 1 on both sides, and I get a -1. I can add 1 on both sides, so I get a +1. And we were told at the very beginning that x equals 2 is one of our solutions. So our roots, we know, are 2, -1, and +1. So we're going to cross through the x-axis at 2, -1, and +1. All right, continuing on. All right, so this time through, we're looking at number 6. All right, and we can see it graphed. Okay, so take a moment, look at the graph, and see if you can figure out any of our factors. What's one solution? All right, so if I look at the graph, I notice that, hey, we are crossing through at x equals -3. So x equals -3 has to be one of our solutions. All right, so now it's asking us, please use long division to find the remaining factor. You could use synthetic division if you would like, but we're going to practice with this long division. All right, so I'm going to remind myself that if x equals -3 is my solution, I'm going to work backwards this time. So one of my factors, add 3 to both sides, so I set this whole thing equal to 0. So one of my factors is x plus 3. So I'm going to go ahead and take x plus 3 and divide that into this x cubed plus 27. Okay, but this time through, I see an x squared, but I don't see any I see an x cubed, I don't see any x squareds, I don't see any plain old x's, but I do see a constant of 27. Okay, so it's going to be really helpful if I have those placeholders in there to help me keep track of what's happening. All right, so if I'm going to use long division here, all right, I'm going to shrink this up so I have a little bit more space. All right, so I'm going to start by taking a look at x and x cubed. And I ask myself, x times x times x squared gives me x cubed. Okay, a little side work happening over here, x squared times x plus 3. Distribute that on through, and I get an x cubed plus 3x squared. Okay, I'm going to go ahead and subtract that out. Okay, x cubed minus x cubed is 0. 0x squared minus 3x squared is a -3x squared. And I'm going to bring down the other terms. Okay, so now I'm looking at my x and my -3x squared. I'm asking myself, all right, x times what is -3x squared? That's going to be a -3x. Little side work over here, I can take that -3x times x plus 3, distribute that on through, I got a negative 3x squared minus a 9x. I'm going to subtract that out. Negative 3x squared minus a negative 3x squared is 0. 0x minus a negative 9x, that's going to give me a positive 9x. Minus a negative changes to plus a positive. All right, now I'm going to take a look at x and 9x, and I'm asking myself x times what gives me 9x, and that's going to be my 9. Okay, so I'm going to take my 9 times x plus 3, distribute that through, and I got a 9x and a positive 27. I subtract that out. 9x minus 9x is 0. 27 minus 27 is 0. So when I divide that out, here's what I get. Okay, so this question is just asking me, is this linear or quadratic? Okay, since it's in the form of ax squared plus bx plus c, okay, I'm seeing an x squared term in here, I know that my remaining factor is quadratic versus linear. Okay, if it was linear, it would just have a plain old x in it, but this one has an x squared, so it must be quadratic. All right, continuing on. All right, we're going to do this again. Somehow our equal sign disappeared on this next one, so let's add that back in. And we're seeing that the graph of x cubed minus 64 is shown for us. Okay. So if we look at this, we're going to find any linear factors hanging out here. Okay. And I'm seeing that, hey, we're crossing the x-axis at 4, so x equals 4 is a solution. So if I subtract 4 on both sides to set this equation equal to 0, x minus 4 has to be one of my factors. Okay, so again, we are asked to use long division. Okay. Synthetic division will get us the same thing, but we're going to practice this long division stuff. And we're going to take x minus 4, and we're going to divide that into our x cubed minus 64. But we're going to add in some placeholders, plus a 0x squared plus a 0x minus 64. Okay. At this point, I would encourage you to pause the video, try to divide this out, and then compare. Okay, welcome back. Hopefully you had a chance to try this out. Let's compare. So I'm thinking to myself, x times what gives me x cubed? And that would be my x squared. Little side work happening over here. I'm going to take my x squared times x minus 4, distribute that through to give me x cubed minus 4x squared. Okay, I'm going to go ahead and subtract these. X cubed minus x cubed is 0. 0x squared minus a negative 4x squared is a positive 4x squared. Minus a negative gives me plus a positive. I'm going to bring down this plus 0x and this minus 64. All right, so now we're looking at x and this 4x squared, and we're thinking to ourselves, x times what is 4x squared? And we're missing a 4x, so we throw that up top. Little side work here, 4x times x minus 4. Distribute this through, and we have a 4x squared minus 16x. We'll go ahead and subtract that out. 4x squared minus 4x squared is 0. 0x minus a negative 16x minus a negative turns into plus a positive, so we have 16x minus 64. Then we're asking ourselves, x times what gives us 16x? Okay, and we are missing a positive 16. Okay, so we'll take 16 times x minus 4, distribute that through, we got 16x minus 64, subtract that all out, and we get 0. Okay, so when we divide this out, we have x squared plus 4x plus 16, and that's our missing quadratic factor. All right, so you may have noticed, and we talked about this earlier, we have two terms that we're subtracting from each other, and we actually have a difference of cubes. The previous problem, number 6, we had a sum of cubes, and we talked about this back in topic 5, I believe, with our difference of cubes and our sum of cubes. All right, so our sum of cubes formula Okay, sum of cubes, we're going to start with our a plus b. And then we're going to multiply that by a squared minus a times b plus b squared. Okay, if we're dealing with our difference of cubes, it's going to be almost identical, but our signs are going to change. So this time through, we're going to do an a minus b, and we're going to multiply that through by a squared plus ab plus b squared. Okay, so the only difference between these things are the signs in between. So our sum of cubes is going to be a plus minus plus, and our difference of cubes is going to be a minus plus plus. All right. We are asked to prove our conjectures here. All right, good time. So we're going to start with proving our a cubed plus b cubed. Why not? Okay, and a cubed plus b cubed, we said our factors were an a plus b times an a squared minus ab plus a b squared. So if we find the area of each of these squares, all right, a times a squared gives us a cubed. A times negative ab is a negative a squared b, and we have a times b squared. In the second row, we have a squared times b. Then we have a negative a times b for a negative ab squared, and b times b squared gives me a b cubed. Okay, if we combine some like terms, we notice that we're going to have an a squared b and a negative a squared b, so that goes to 0. We also have a negative ab squared and a positive ab squared, so when we combine our like terms, we just have an a cubed and a positive b cubed. Okay, if we want to prove our difference of cubes, so a cubed minus b cubed, okay, we're going to do something almost identical. Okay, but this time through, we're going to have an a with a negative b as one of our factors, then an a squared with a positive ab and a positive b squared. If we find the area of each of these squares, a times a squared is a cubed, a times ab is a squared b, and then we have a times b squared. Second line, we have a squared times negative b for a negative a squared b. We have a negative ab squared and a negative b cubed. Okay, negative a squared b and positive a squared b go to 0. Negative ab squared and a positive ab squared go to 0. So when we combine our like terms, we have an a cubed minus b cubed. So we have proved both of those lovely formulas for our sum of cubes and our difference of cubes. Okay, a little bit more to practice. Okay, I would encourage you, if this is making sense, to try to pause the video and factor these and then check in. All right, welcome back. All right, so this first one, I'm noticing I have subtraction. All right, I know I can take 2 to the third power to get 8 and x to the third power to get x cubed. Okay, and I can take 5 to the third power to get 125. Okay, if you did not remember what this was, you can hit up your Graph and Calc. And on Graph and Calc, under the Math menu, we see option 4 for that cube root button. I can take the cube root of 125 to get 5. All right. So cruising along, my base terms are 2x and 5. Okay, so difference of cubes says I'm going to subtract those in our first set of parentheses. Then I'm going to square my first term. Plus, I'm going to multiply those two base terms together, plus my last term squared. If I clean this up, I know that 2x quantity squared is going to be a 4x squared. 2x times 5 is a 10x, and 5 squared gives me 25 when I factor this fully. Okay, let's try it again. This next one, I know I can take 3y and cube it to get 27y cubed. I can take 4z and cube it to get 64z cubed. This time through, I'm noticing that I have the sum of cubes. So I'm going to take those base terms and add them together in the first set of parentheses. Then I will square the first term for 9y squared, multiply those two terms together for a 12yz, and square the last term for a 16z squared. Okay, last one. This one's a little bit trickier. I'm going to cube p to get p cubed. And I'm going to cube 6r squared to get 216r to the 6th. Remember, we multiply those double exponents. Since it is the difference of cubes, I'm going to start by subtracting those base terms in the first set of parentheses times the first term squared plus the two base terms multiplied together plus the last term squared for 36r to the 4th. All right, hopefully this is making sense. Please let me know what kind of questions you have. Your homework is to take a look at the next question, number 10, and then on Agile Mind, you're going to do more practice, 9 to 13. All right, good luck. See you soon. Bye.